All right, and we're on to the last section for chapter 2, which is section 2.8. This is the second video of that section, okay? So in the first video, we talked about function operations and then some composition of function stuff. So we're going to start here in example 8 by showing that g of f and f of g are not the exact same thing. So basically what we're going to do is we're going to find g of f and we're going to find f of g and show that they're not the same, okay? Because it's very much true. So g of f looks like this. And so that's taking f, plugging into g. So we have g, so 3x squared, which is 2x minus 5 squared, plus x, which is 2x minus 5. Remember, plugging in f into g. Okay? A little bit of quick math here. Square this, so you get 4x squared minus 20x. What is that? Plus 25. Plus our 2x minus 5 here. Distribute the 3. Combine like terms, minus 58x plus 70. So there is our g of f of x, okay? So we'll do the same thing here for the f of g of x. How's that orange look? Just fine. So we plug g into f now. So we have 2, 3x squared plus x minus 5. So that's 6x squared plus 2x minus 5. And those are drastically different functions, okay? So it should be pretty clear that you don't want to just interchange these, okay? And what happens is the domains are very different, lots of stuff different. So that is not a, you can't be symmetric with that. You can't just flip around the order. You have to be careful with the order that you put it in or else you will mess it up, okay? That's what that is supposed to show. So on to example 9. So we're going to find some functions that actually form a composition. So we want to find functions f and g such that the composition f of g is 4 times all this minus 5 times all this minus 8. So my suggestion is you want to look at it like a big picture and a small picture. So in this, we have a function that is plugged into another function. And so you want to look for any commonalities. And so what I see here is I see this 3x plus 2 being plugged in. And so I want to make my g of x function be 3x plus 2. Okay? And so if I kind of mentally cover these things, right, I kind of see a big picture function. So my big picture function that I see is 4 times x squared. I don't know why I put parentheses there, right? Because if I took 3x plus 2 and plugged it in here, I would get 4 times 3x plus 2 squared minus 5x, right? Because if I plugged in this into here, I would get this minus 8. So there are my two functions. And so now I have f of g of x, where these are the two functions, and that's exactly what I would do. Okay, so it just takes a little bit of thought. There's no like quick algebraic way to find this, but it is very doable. Okay, go ahead and turn the page. We're on this one. So we're going to use some operations to determine the following. I feel like this comes in an earlier page, but let's go ahead and do it anyway. Why not? I think I'm very, very out of order. I definitely am. Super out of order. So if you're really confused, that's why. Let's go ahead and do these. Do I want to do it in this video? Yeah, let's go in this video. So very out of order. I'm sorry, but make sure you just watch both videos. Take all the notes. My pages aren't numbered. They're obviously numbered here, and I butchered it. So let's start with the proper ones. We'll start right here. Ignore my mess ups. Okay. So we're going back to the function operations. Okay, so we're just adding, subtracting, multiplying, and dividing. Okay, and so just bear with me. I don't want to remake these videos, so we're just going to roll with it. So f plus g, we just have the adding of the functions. So here we have f of x plus g of x, which is x squared minus 3x plus 4x plus 5. This is x squared minus 3 plus 4 is 1 plus 5. That is f plus g. Okay, nothing crazy to it. F minus g, this is just the same thing as f of x minus g of x, which is x squared minus 3x minus, so this is really important right here. For minus g of x, I'm going to put g of x in parentheses. So what happens here is you end up not distributing this negative, which really messes up your answer. Okay, so x squared minus 3x, distribute the negative, combine like terms, and that's it. Okay, that's all there is to that. So nothing crazy here. Again, this is going to feel a little bit easier than the composition. Okay, f times g. Again, this is just f of x times g of x. And so we get x squared minus 3x times g of x, which is 4x plus 5. Lots and lots of foiling here, so we get 4x cubed minus 12x squared plus 5x squared minus 15x. Combine like terms, and you're done. Okay? And the last one, f over g. So this is just f of x over g of x, which is x squared minus 3x over 4x plus 5. I don't think we can factor that to make it any nicer. We really can't. Okay, I mean, you factor out an x on top, right? But you get x times x minus 3. Nothing happens here. Okay, so now for part E, it says find the domains. We'll do that in orange. Now, again, the domain is going to be the more restrictive of the two, okay? But they're pretty easy because the domain of this one is going to be all reals, right? Just a polynomial, right? This is going to be a parabola. The domain is all the real numbers. Same thing here, okay? So these are really nice. So for the first three, it's going to be very easy, right? Because what we end up with is another polynomial, another nice function. The domain is just going to be all real numbers, nothing to it. Same thing here. And same thing here. Okay? None of those are bothered because neither of the domains is restrictive. There's nothing happening that actually bothers those, and so those are just all reals. D is where that actually comes into play, right? Because again, it's the more restrictive, but the bottom of something can never be 0. So this g of x can't equal 0. So what we're going to do is we're going to take the bottom, set it equal to 0, and find out where that fails. So to find that, we do 4x plus 5 equals 0. Solve this. And that's the number that causes us problems, right? So our domain is going to be all real numbers except for negative 5/4, which is written like this. So negative infinity up to 5/4 union with negative 5/4 to infinity. That is going to be our domain, okay? And on to the actual last page. I again apologize for the mess up in order and the confusion earlier. Okay, so here we're going to find these specific function combinations given what we have in a picture. So there's some homework problems like this, but let's go ahead and do it. So here we're going to find f plus g of 1, f minus g of 0, f g of negative 1, and f over g of negative 2. Okay, so a little bit of work here. So again, let's call this a capital A maybe, capital B, capital C, and capital D. Okay, so we'll number them. So A here, remember this is going to be f of 1 plus g of 1. So we need to find the functions evaluated at those points. So f is the upside down parabola. F of 1 looks like 1, 1, 2, 3. So that's going to be 3, right? So if I plug in 1 to the f function, I get 3, plus g of 1. G of 1 is the absolute value function, so that's 1. Okay? And so this is 4. That is our f plus g of 1. If I took this function at 1, 1, and this function at 1 is 3, and added them. That's all you do. Okay? For B, you subtract them. So f of 1 minus g of 1. So that's 3 minus 1, which is 2. For C, oh, it's f minus g of 0. Of course it is. Of 0. So let's look what it is at 0. F of 0 is going to be 4 minus g of 0 is 0. So we just get 4. Okay? C is going to be f of negative 1 times g of negative 1. So f of negative 1 is 3 again, times g of negative 1 is 1, so we get 3. And the last one is D, which is going to be f of negative 2 over g of negative 2. So we get f of negative 2, plug in negative 2, 1, 2, you get 0. Over, doesn't really matter, but g of negative 2 is 2, and so you just get 0. Okay? That's kind of the idea, and we're going to do this for all three of them. Okay? So it's going to be pretty quick here. All right, so for the first one, A, we have f of 1 plus g of 1. F of 1 is 1, g of 1 is 6, and so we get 7. For B, f of 0 minus g of 0. F of 0 is negative 1 minus g of 0 is 4. This is the nicest version of this question, right? For C, so it's f of negative 1 times g of negative 1. F of negative 1 is negative 3. G of negative 1 is 2. So we get negative 6. And for D, we have f of negative 2 over g of negative 2. F of negative 2 is negative 5. G of negative 2 is 0. So here is an issue, right? This one right here, that's undefined. Okay? Remember, you cannot divide by 0. It causes huge issues. Okay? And we are on the last one. C, the same things. Okay? And so this will take a little bit longer. For A, we want f of 1 plus g of 1. So f of 1 is 3 plus 4 is 7, plus g of 1. So that is negative, the absolute value of 1 is 1, so negative 1. And so we get 6. Okay? B, f of 0 minus g of 0. F of 0 is 4, minus g of 0 is 0, so we just get 4. C, we want f of negative 1 times g of negative 1. F of negative 1 is negative 3 plus 4. That's 1. And g of negative 1 is, well, absolute value of negative 1 is 1 minus. So we get negative 1. And that is negative 1 itself. And D, we have f of negative 2 over g of negative 2. F of negative 2 is negative 6 plus 4 is negative 2. G of negative 2 is just going to be negative 2. And so we get a positive 1 as our solution. Okay? So again, I went a little out of order, but hopefully you got all the notes from the 2 videos. Sorry they got a little bit long, and I got very confused because I didn't know where the notes came from. But we got it all done. So if you have questions, let us know. Otherwise, good luck studying for your test. Have a good day.